Hello and welcome to Distributed Systems and Blockchain in the News. My name is Thomas Bocek. And the first article that we're going to look at was sent to me by Mirko Stocker. Thanks for that. And it's the following article here. This one. So this article, it's a beautiful website that visualizes several load balancing algorithms. So the author starts with visualizing the problem. So here we have a requester, here we have the server, everything's green, no message gets dropped, so that's all fine. However, if we send more requests than the server can handle, then some of those messages get dropped. So the answer for that, obviously, also that what we discussed in the lecture, is to add load balancers as seen here. That works well. Here we see that we have a round robin load balancer, so we send those requests to those servers in order. Once we reach the last one, we start with the first one, and so on. However, the problem is if the server cannot handle those requests. So for example, if a request asks many rows, needs a bit more load of the server, some requests are a bit lighter. So if those are not well balanced, then we can see that some requests gets dropped here, and the solution for that is to add a queue. Once it's in the queue, it won't get dropped, and due to the algorithm, then eventually the request gets served. However, this adds latency, so if your request is in the queue, you have to wait a bit until the request is being handled. However, there's still a problem if, for example, you have slow servers, fast servers. That's what he did here with the colors. So black is fast and light gray is slow. And here we see we have dropped requests. And one way to solve this is to use a weighted round robin. So to assign weight, that means this fast server can actually handle more requests, so it gets also more requests, and it still can be suboptimal since there still can be requests not going through. So what can be done? For example, we can move away from round robin. So up to now we only saw round robin, and here, for example, we have a mechanism that is looking at the least connections, because the load balancer knows I send a request there, I didn't get a reply yet, so I know that there are 3 requests pending, for example, and I will send it to the server with the least pending requests. And this works quite well. And you can also look at latency. So I mentioned if you have in the queue round robin, might not be optimal for latency. The author also looked into latency, how the latency can be improved, and eventually he mentioned one last article, the peak exponentially weighted moving average, where he actually looks how fast the server is, and if, for example, the least connections, there are some servers free, and I will send it to actually the fastest one to get the fastest reply in order to reduce latency. He also compared those ones and showed the graphs here. And here what I also like a lot is here the playground, so you can play with random, with least connections, increase the requests per second. So that's a very beautiful site. Please play with it, have a look at it. The next article is about self-hosting emails. It's this article here. And since many years, I'm also self-hosting my emails, my personal emails, not my company emails, to not miss out the fun of configuring all those required mechanisms to not land in the spam folder. So you will for sure need DMARC, DKIM, DANE, SPF, and I briefly mentioned what those are. SPF stands for Sender Policy Framework and is an email authentication protocol that enables domain owners to specify which email servers are permitted to send emails on behalf of their domain. And this information is published in the DNS record. And when a receiving server gets an email, it can check on this DNS the SPF records and then knows which server is actually authorized to send emails. So this is one mechanism. Another one is DKIM or DKIM, domain keys identified email. This is an email authentication method that it adds a digital signature to the email header. So this signature is generated using a private key that you can create, and you publish actually the public key also in the DNS, so that receiving party can get the DNS and check if this signature is actually valid. And DMARC stands for Domain-Based Message Authentication, Reporting and Conformance, and is also an authentication protocol that uses SPF and DKIM. It allows domain owners to specify how receiving mail servers should handle those unauthenticated mails and reducing the risk of spoofed messages. With DMARC, you can also set some reporting mechanisms that helps you to monitor what spam messages are out there. And the last one, it's not widely used. I really like these mechanisms, but it didn't pick on for some reason. It's DANE, DNS-based authentication of named entities, and this is a protocol that uses DNSSEC to provide additional security for TLS connections. Also could include email. So DANE allows domain owners to specify which certificates or certificate authorities are authorized for their domain. This could prevent man-in-the-middle attacks. Like I said, not that frequently used, unfortunately. So all you need is to actually configure those to make it work, to not land in the spam folder. And the author here seems to have a problem with that. And he showed that his emails are being queued in these graphs here. However, I see that they are getting back to normal after a couple of hours. And what I also like is here this questionnaire down here. Should I host my own email server? Well, the answer is almost no, but if you like the fun, it's yes, I can recommend it. And back to those spam emails, I made the observation that my emails are landing once a while in a spam folder from Microsoft Outlook. They also have this email service, and compared to Google, I think that this Microsoft email service is more aggressive, and my emails lands often more in those Microsoft spam folders than in the Google spam folder. So I made a rather more positive experience with Google, a bit more negative with Microsoft, but I agree that the big providers could easily kill self-hosting domains. The next article is about protocol comparison. It's the following article here. It's a detailed comparison of REST and gRPC. REST stands for Representational State Transfer and is an architectural style for designing networked applications. That was also being used by you mostly in the challenge task. So if you contact a server from within the browser, most likely it will be REST. gRPC stands for Remote Procedure Call, and it's an open source framework for building APIs. It was developed or is still developed by Google. And in this article, he mentions also SOAP and GraphQL, but he is comparing REST to gRPC, and I can recommend this comparison. I think it's quite good, and also the conclusion is quite good. Both have their advantages and disadvantages. REST is more widely used, and if you're in the web, most likely you will be using REST, and gRPC has advantage in server-to-server communication. So I think this is a good conclusion. Since I like to show the submarine cable map in my lectures, I have now an additional map to show, and it's a satellite map here. So here you can see Starlink and OneWeb and GPS satellites. Starlink and OneWeb is used for internet communication, and interestingly, you can see that, for example, OneWeb is in a higher orbit. So here we see Starlink, and when we look at OneWeb, we see here they are in a higher orbit. We go back to Starlink, and here we see they are in a higher orbit. That also means that the latency with Starlink is lower. It's around 30 to 40, 50 milliseconds, roughly about that. And OneWeb is expected to be around 100 milliseconds. And if you go to GPS, here you see they are in a way higher orbit. Here we see the GPS satellites. That means for Starlink and OneWeb, you have higher latency, and HTTP reducing one round trip gives for sure a boost here. The last article is about 2FA, and it's an article from Cointelegraph. It's based on this announcement from Google here. Google announced that the Google Authenticator now supports Google account synchronization. So that means your passwords will be, or the secrets, they will be synchronized with your Google Clouds, and you can have it on multiple devices. And what they also write here is that it will improve security and convenience. So here, this change means users are better protected from lockout, and that services can rely on users retaining access, increasing both convenience and security. And this article is actually arguing against this increased security, since they argue it's less secure. And they even suggest don't turn it on, because if those secrets are now synchronized with the Google Cloud and your Google Cloud gets compromised, the hackers would have access to all your 2FA secrets. That's true. So I would also not consider it to be more secure, but most likely this article was written by a marketing team, not from security experts. Before turning it on, make sure you know what you're doing. The secrets will be then in the Google Cloud, and if something happens with the Google Cloud, then all those 2FA secrets may get compromised. What I also like in this article is they mention other 2FA issues, for example, with SIM cards. and SIM cards should actually not be used as 2FA, since SIM swap is quite easy to achieve. And SMS as 2FA should never be used, actually, because this here, this is a real incident. Happened to Mr. Ferguson. His password was compromised. Okay, bad. He chose SMS for 2FA, and there was a SIM swap performed for his SIM card, so the hackers could get access to his Coinbase account and steal all the money. Ideally, don't use SMS for 2FA, use time-based one-time passwords, for example. I think those are better suited than SMS 2FA.